Problem number 4 of Project Euler, largest palindrome product. A palindromic number reads same both ways. So if you read from left to right, 101101, or if you read it from right to left, 101101, both is same. The smallest 6-digit palindrome made from the product of two 3-digit numbers is this. Find the largest palindrome made from the product of two 3-digit numbers, which is less than n. Okay. Find first line contains t, that denotes number of test cases, and this is followed by t lines, each containing an integer n. Okay, so print the required answer for each test case in a new line. Right. So what we will do in this question is we will actually pre-compute all the valid numbers. So if you look at complexity, so 100 test cases and 10 raised power 6 values. So it is 10 raised power 8. And we can basically pre-compute all the valid numbers in 10 raised power 6 into 6, 6 being the number of digits in a number, which we will use in checking if it's a palindrome. And once we have pre-calculated all the valid numbers means palindrome and product of two 3-digit numbers, then we can answer this question, find the largest palindrome, in we can answer that in linear time. So what we can do is we can start with n and look at n minus 1, then n minus 2, then n minus 3, and whichever is valid number we can just output that. And also, if we calculate which are the valid numbers, we can pre-process that information to answer this query in constant time. But you can try to practice that if you can get that done. Let me see if I can implement that. So let's pre-compute. Before looping for the input, we will pre-compute. What will be the pre-computation? We will try to make an array which will be is valid. Let's say max size is 1e6. Right, so not 1e6. Okay, 1e6, correct. So 1e6 means 10 raised power 6, which is equal to 1000 into 1000. Like any product of two 3-digit number cannot be greater than this. Dot fill 0. Right, so is valid. Then how do we pre-compute it? We iterate over all the possible 3-digit products. 1000 G can start from I actually. And then is valid I into j is equal to true. But this is actually not correct. We have to check if it is a palindrome as well. So we will just call it as pal. If a number comes, then we'll just convert it to string. Right, and you can, okay, so is valid is equal to is pal is pal integer. Right, so we already know it's a product of two 3-digit numbers, and if it is a palindrome, then it will be set to true. How do you check palindrome? Right, so what I will do here is let's take an example A, B, C, D, A. So I will have two pointers, one at first and one at last. Then I will check if the character matches. If it matches, then I will come inside and check if the last two character matches. If they keep matching for all of the string, then we have a palindrome. Else, right? So I'll match A and A, it will match. Then I match B and B, it will also match. But when I come at C and D, then it will fail and it should return false, right? So while low is less than high, remember to increment it, and high is to be decremented. Okay. So if s of I is not equal to high, then return false, because we know there is something, it's not a palindrome, otherwise return true. So now we have all the valid numbers here. So let's just check if the given number is valid, right? Is valid. I think 101101. Yep, and 793397. We'll check it later. As of low. Okay. All right. Yeah. So generally, it's a good idea to have a function which returns this value so that it's natural to read. But yeah, so it is true. And 793397. 793397. It's also true. So seems to be working. We will see if it fails. Then we will correct it. And how do we check if what is the largest number? So it has to be less than n, because question mentions that it has to be less than n. So what do we do now? While true, um, then n is, if is valid, then what we do is we console log n and we break. Why do we know it will always break? Because there is this lower limit. So we know that input will always be in this range. So this will always be the answer. So we can do while true, otherwise we'll have to do things like when n is above certain number. But let's try to run this code. I'm not printing anything inside. So this gives correct. Let's submit this code. So what is the time complexity here? This is n, and for each test case it will be t into n. So that's why it is passing. So I was mentioning that you can also do it in constant time by pre-computing. Let's see if we can make that happen. Okay, so so I'll make smaller. So what will it contain? I will pre-process this array so that smaller will contain for every index, which is the last valid number. Okay, so smaller will be, so yeah, so if you don't know what pre-processing means, is basically pre-processing data before answering the queries so that queries are faster. So we spend some computation time here so that each of our queries is faster. Okay, so let's do this. So array of max, we will fill it with -1. All right, then let's go for, okay, let me -1. Like I equal to 0 and I is less than max. So how do we fill smaller? If, oh, we have to find less than. Okay, so smaller I is equal to pre, right, which is the previous number, which is valid. Got it. But if you have, now you have to update pre. If is valid, if I is valid, then pre becomes I, because after this uh, I will be the smaller, I will be the smaller number which is valid, right? Think about a particular case. You are at a number, and whatever is the value of pre will be the value of smaller I, right? But if I itself is valid, then you have to do it after assigning smaller I. Why? Because if you do it before, then smaller I will point to I, and we want less than I, right? So that's what I'm doing here. And once I is valid, then for every next number, it will be the number which is less than that, and multiple of 2 3 digit numbers, right? So let's try to run this. Now this thing will actually become very simple. Smaller of n. Let's run it once to see. So it gives correct answer. So what did we do? We pre-compute all the. Let's submit it once. Let to see if it is correct. Then I'll explain. So this is correct. This is actually way faster than the first solution because it is answering queries in constant time. So we pre-processed and found all the values of valid numbers, which are basically product of two 3-digit numbers and are also palindrome. What am I doing here is, let's say this example. So let's say our array was at index x. Let's take some proper example. So this one, then 1 0 1 0 2, right? So suppose this was my array, right? What will be the value of pre when I am at 1 0 1 0 0? Because we know this is the smallest number, so in this case the value of pre will be -1. When I come here, pre value will always will again be -1. So answer for 1 0 1 1 0 1 is -1. But then I check if 1 0 1 1 0 1 is valid, which is true, right? So I set previous number to be I. Basically, previous become this, and that is why at 1 1 0 1 0 1 1 0 2, the smaller will point to this number. But this is not valid, so pre will remain same. Same for 1 0 1 1 0 3, the answer will be this. So this is what this pre-computation is doing, and that is why our queries become faster. So that's it for this question. And if you want to solve the original problem, uh, find the largest palindrome made from the product of two 3-digit numbers, right? Then basically you just need to do this. Oh, okay. So because I wanted to do, okay, so there are 6 zeros, so 6 nines, 3 4 5 6. All right, so this should be, so it is asking largest palindrome, and it cannot be greater than this number, right? 9999999. So this should be the answer. So it has to be smaller than this, basically. So let's try to paste it here, and this is correct, right? How did I find 999? So yeah, so it is basically this. Maximum product has to be less than this, right? And I just subtracted 1 from it. So that's it for this question. Hope this was helpful. Thanks for watching.